Hello, I'm Marcus Grodi, the founder and president of the Coming Home Network International and host of the Journey Home program here on EWTN. And I welcome you to the second episode of the Science Before Science, a guide to thinking and believing. I'm here with renowned physicist Dr. Anthony Rizzi, the director of the Institute for Advanced Physics. He is serving as our guide in firming up the foundations of our thinking. Last time, we talked about the deep decay that has set into our culture and the need for returning to truth. We found we need both knowledge and belief, as a bird needs two wings to soar. Both faith and reason are needed. Dr. Rizzi, which comes first and why is this important?
Well, we saw last time that knowledge comes before belief. Knowledge in the most proper sense, what we call proper knowledge, are those things that we know with certainty from direct touch, sight, hearing, etc., and if needed, our own reasoning.
And belief?
Here in this series, by belief will mean those things which we take on the word of another, but it can also mean things that we have evidence for that we make hunches about.
So there is an order of knowing and believing. Knowing comes first. We often hear people talking about having to start with assumptions. Is this what we're saying?
Actually not. As you know, there are things that we simply know. For example, color and shape are things we just see. Another example is the number 2. We don't have to figure out what 2 is, we just see it. Such things are the starting points for further knowing and believing. The first things we know are not hypotheses, but are things we see directly. These are the things of common experience. Common experience is the very simple contact with the physical things around us. It is the foundational, unequivocal ground of all of our knowledge, including the modern sciences.
What about the modern sciences? They also depend on these first simple principles. So in other words, there is a chain of knowledge, an order of knowledge.
Yeah, in the last episode we saw that there is proper knowledge versus improper knowledge in a chain. And today, the specialized sciences such as physics and chemistry also add another twist. They are explaining things in a particular specialized mode. For example, in my field of physics, we explain things in terms of the language of mathematics. That is, we look at the world as mathematical. This is in sharp contrast to the science before science, because it's broad and general in aim and method.
What exactly, you've used this phrase before, what exactly is the science before science, which is what you chose as the title for your book and for this series?
It's the study of all the things we know before we come to use the specialized experience and knowledge of modern science, for example.
As we've seen, we also need the science before science to believe things as well. Furthermore, believing something helps to move our knowledge along because we don't have to reinvent the wheel. If each generation had to rediscover what our forefathers did before us, we would never have advanced beyond primitive man.
Our viewers, for example, see us through TV rather than directly, which means they have to exercise an element of faith. Our images might be holograms or otherwise tricks of cinematography, which many such tricks can be done now. Our words might be scrambled to give different meanings than what we initially say here.
Our signal light is flashing red. We have some children watching in the studio that we can get comments from.
Here he comes.
Okay.
Hello.
Right. Now, what's your name?
Nathan.
Nathan. All right, here, come up here, Nathan. Now, let me ask you a question. Is watching someone on TV the same as seeing them in person?
No.
Well, Nathan, what's the difference?
It's a picture of somebody.
And why is a picture not the same as a person?
Doesn't have a mind, brain, or soul.
What is it then?
It's a thing.
Is there something about it that's like me then, if it's a picture of me?
Yes.
What?
Shows you the same color of skin, what color his clothes and his face is. It might have dampness on his face. It might show that.
Nathan? Will it show his shape?
Yes. And what's on his shirt.
All right. Could the TV picture be wrong?
Oh, yes. It get all scrubby when wires aren't working right.
Could somebody make me look different using this? Could they trick you?
Yes, by not plugging the wires right.
So you're talking about the antenna wires?
Yes.
Thank you for joining us. We appreciate you doing that, Nathan.
Thanks, Nathan. As is pointed out in your book, there was at one point a whole group of people who thought the Apollo moon landings were a hoax done on television.
Yeah, it's interesting to remember that TV is several steps removed from direct contact with the objects we see on it.
It requires an element of faith. Belief and trust are often starting points for our knowledge.
Yeah, recognized and consciously chosen belief is a very important part of living and growing in wisdom. As a result, to develop wisdom in all of the areas of our lives, it is essential that we hone the skills at identifying trustworthy sources, for no one can learn everything on his own. This requires remembering where we received information from.
That's an important, interesting insight. Let me summarize our 2 points that we've been discussing here. One, authority is needed because belief is an essential element in life. 2, thus we should develop reliable habits of identifying trustworthy sources of authority.
Yes, and to believe something, we must first know something. Knowledge, again, comes before belief.
Let's return to an example from the first episode, one of the Earth's roundness, so that we can really make this concrete. Let's use the image of a tree to illustrate the dependence of belief on knowledge. We'll see this on screen.
Okay, if someone tells you, as they no doubt have, that the Earth is round, before you can have the option of believing or not believing, you must at least know a few things. You must know, at least in a vague way, what is, what roundness is, and what Earth is.
Let's say that I accept the word of someone that I trust. I believe what they tell me. For example, a teacher in a school, for example, and we have all kinds of people in our life that we trust who tell us things, and because of this trust that I have in them, they tell me the Earth is round. Obviously, I've heard this many times from many people. What next?
Well, in between those times, someone challenges your thinking and says, but it doesn't look round, it looks flat.
Well, I might respond, yes, but that doesn't decide it. The Earth, for example, could curve slower than we're able to see. So to determine which is true, we somehow need to test it.
One way to do this, which our viewers could do for themselves, is to recognize that if the Earth is flat, then we should not be able to see anything more by climbing up to a tree or even the top of the tallest mountain. Indeed, assuming there are no trees or buildings in the way, if our eyesight were telescopic, we could see whatever there is in the distance, no matter how far away it is, right from where we sit.
Let's look at the screen and we'll see our own experiment on this.
Okay.
All right.
So
I can see it perfectly well.
I see you.
We're on the supposedly flat Earth.
Right, this flat Earth, and why don't we walk a mile and see if we can see each other?
Okay.
What do you think? All right.
All right.
I can see.
I can see it perfectly fine.
You should be getting
flat.
Should be getting
a tad smaller.
Yeah.
But
see you fine? Yeah. And funny, I can hear you perfect.
My tie changed in the process. I'm not sure, but here we are.
Yeah, I don't know what happened here.
Okay, here we go. Now what?
Okay. Now why don't we go a couple thousand miles?
All right.
Long walk, but let's try.
Okay. Give me some time. You know, I'm getting old.
Okay. All right.
All right.
Boy.
I can still see you.
I can see you. You're
Okay.
smaller, but I can see all of you.
That's right. So
All right.
what you're saying is that if we went 100,000 miles, we'd be just a tad smaller, but we would still see each
We'd
other.
get smaller and smaller, but we'd still be able to see each other. We just need bigger and bigger telescopes. We'd see everything.
Okay.
All right. So why don't we come back and get back to our business. Okay. We're on the globe now, a round surface rather than a flat one. So why don't should we try the same experiment and see if we can show the curvature of the Earth gets in the way when we're...
All right, now we stand here. Obviously the curvature, this close, we would never be able to detect that. It would still seem like the world is flat.
Right, not that sharp of a curvature.
Okay, let's try a mile.
Let's try a mile and see what we...
All right.
All right. So that's about a mile.
What'd you say? Oh, I can hear you just fine, but you're an awful lot smaller.
Yeah,
I can still see you.
I can see you. You're smaller and
looks like the Earth has done something between us.
Same thing.
Slightly, but I can
very slightly.
I can still see you pretty well. Your feet are a little covered up by this bubbling of the Earth, right?
I can see you fine, and I can hear you.
But at this point in time, people could still imagine that the Earth is flat.
Yes, at this point in time, people could still imagine the Earth is flat.
Okay.
All right.
So now how far are we going to go?
Why don't we go several thousand miles?
Okay, in a couple seconds?
A couple seconds.
It's going to take quite
we're fast runners. All right. Yeah, I'm always amazed at how 1,000 miles is like a mile.
Oh, there you are. What are you saying? I can't hardly hear you.
I can't hardly hear.
I can't see at all, though. That's the main difference.
Yeah, not me neither.
Hello?
Not there, Marcus. You're gone. But I can hear you. I shouldn't be able to hear you, but magic of cartoon land. But can you see me at all, Marcus?
Nothing.
How about this?
Can't see a thing. Can't see a thing.
Okay, same here. Hey, why don't we try stretching? See, maybe we stretch.
Okay.
Whoa. Hey, Marcus.
There you are.
I see you. Hey, I see you waving. Oh, cool.
You look strange, but I can just barely see you.
You lost some weight.
Oh, jeez.
Hey, hope you got to eat some more, Mark.
All right.
All right, should we go back down?
Okay, it sounds good.
Okay. All right. All right. Hey.
Now what did we prove?
Well, we showed that the Earth is actually round because we got the curvature of the Earth got in the way of us being able to see each other. And whereas if it's flat, no matter how far you go, as long as you have good enough vision, big enough telescope, we can see each other.
All right.
This is one of the ways that medieval man knew the Earth was round. He would climb up into the ship's crow's nest, and we have this on screen. He could see further. Today, some have direct, proper knowledge of the Earth's shape. For example, those astronauts who've actually went around the Earth and watched themselves go around. Now, medieval man knew the Earth was round. We are taught that they thought the Earth was flat, which is one of the many false myths about the Middle Ages.
And many would be shocked to hear that because they've always presumed that. We even tend to include the High Middle Ages, which in fact is a very bright period in the history of civilization, include that in the, quote, Dark Ages.
Even though this is when, for example, as you're pointing out, some things like the first universities sprang up.
Let's reconsider the example from the first episode that we discussed about the atom, determine what's faith and what's knowledge. Indeed, we'd like to know what's true and what's false in our understanding of the atom. We've heard many things from our teachers and from the media about our connection in terms of, as human beings, being created of atoms. We are made of atoms. Where do we go from there?
Yes, this is obviously something which most believe rather than know in the proper sense. Our understanding of the atom is faith based on the authority of the scientists who have done the experiments and done the actual thinking. But there are two fallacies that are attached themselves to the good science, in particular to the fact that we are made of atoms.
As we saw in the last episode, these fallacies are related to the statement that atoms are mostly nothing. I want the audience to remember what they've been taught, that atoms are mostly space or whatever there is in the midst of that. So therefore, the conclusion would be, if we're made of atoms, then we must be made mostly of nothing.
Right. And this emptiness we're taught is just nothing. How can something be partly nothing? Is the first fallacy. The second one is if I combine some pieces to make a new whole, are the pieces simply the same as they were before we combined them?
See this on the screen. This last fallacy would make the atoms that are a part of me exactly like bricks that make up a house.
Yes, we have a real paradox here. We are obviously much more than atoms because we can understand that we are made of them. Only something much more than a mere pile of atoms could understand that atoms exist, or even what an atom is.
So, what's the way out of this conundrum?
Well, we have to remember to go back to our common experience. It's those things that we have direct contact with that we will then use to understand the things that are further from our direct contact.